Hello, welcome to physics class. My name is Jimmy Gabriel. Today we're talking about sound waves. Now, here are the objectives of this topic. Now, the first thing we'll be talking about is the production and transmission of sound waves. Sound wave is produced by a vibrating body. The vibrating causes the surrounding air to vibrate, also producing a disturbance of the air. This disturbance travels out from the source of vibration in the form of longitudinal waves. Last time we talked about types of waves. We have longitudinal waves and transverse waves. Transverse waves are those waves that travel perpendicular to the direction of waves, while longitudinal travel parallel to the direction of wave, that is, they are in the same direction. Like one part is refraction and one part is also compression. Now, almost any object can vibrate and hence the source of sound. Example of such is a turning fork, whereby when you hit, it produces a sound. Different turning fork produce different sound. Now, propagation of sound waves in air. Sound waves are propagated through the air by displacement of the air molecules. These molecules vibrate in a direction parallel to the direction of the traveled waves. Now, when the sound comes out from a speaker, the air around it are set into vibration. Now, the vibration is in the direction while the air also moves along with it. Now, the air that is set into vibration spread out to the observer before they can hear the sound. Waves of this nature are called longitudinal waves. The air are set into vibration. Now, velocity of sound waves. The velocity of sound waves is given by the relation V equals to F lambda. I believe we have done this in the previous class. Now, the velocity of light is 3 times 10 to the power 8 and is far greater than the velocity of sound. Now, from experiment, it was discovered that the velocity of sound equals to 330 meter per second, although this speed is for the speed of sound in water. Now, the reason why a flash of lightning is seen before the accompanying of sound of thunder, you tend to see the light first before the thunder. Suppose the sound of thunder was heard 10 seconds after the lightning, then the distance between the observer and the storm center is given by this. From our knowledge of S is equal to Vt. Now, the distance between the observer and where the storm is being emitted. Now, the speed of sound in air is equal to 330 times 10, which is the time the sound was heard, is equal to 3,300 meters, which is 3.3 kilometers away. Now, the speed of sound varies from one medium to another. This is the speed of sound in air at 0 degrees Celsius. It is 330 meters per second, while in water it is 1,500 meters. And in steel rod, like metal, it is 5,000 meters per second. That is, sound travels faster in steel rod than any other medium. Now, example, what is the wavelength of the sound from the turning fork, which vibrates at a frequency of 250 Hz in air? Take the speed of sound to be 330 meters per second. Now, this is a turning fork. When it struck this turning fork with an object, it produces sound. The air around it is set into vibration. Now, every turning fork with its own frequency. Now, this frequency of this turning fork is 250. Now, we know the sound it produces, the speed is what? 330 meter per second. Now, what is the wavelength of the waves that is being produced? Now, from here, we know V is equals to F lambda. That is, from here, our lambda equals to 1.32 meters. Now, a source of sound produces sound waves in air of wavelength 1.6 meter. If the speed of sound in air is 330 meter, the speed of sound is always constant, is always 330 meter, unless otherwise stated. Find the period of the vibration. Now, first of all, we use our wave equation, which is V equals to F lambda. Substitute for F for wavelength and the speed, and our frequency equals to 200 meter. But F equals to 1 over T, and T equals to 1 over F, which is equals to 0.005 seconds. Now, echo. Echo is the sound heard after the reflection of sound wave from a plane surface. Now, look at when the sound is being produced from here. When the sound is produced from here and it meets a surface, it will be reflected back depending on the angle. It will be reflected back towards an observer. Now, like waves, sound also undergo reflection property. Now, echo is the sound here after this. Suppose the reflecting wall produce the echo X meter away. Let's say this is the wall, and this is the sound from here, X, and the reflected sound is being observed here. Now, you can see the distance to is X, while the distance from is also X. Now, we know that the speed of sound is V. Now, from here, we say S is equals to Vt. Now, the total distance traveled is equals to x2 plus x flow, which is x plus x equals to 2x. That means our distance equal to 2x equals to Vt. Now, from here, we can calculate the time. We can use this formula to calculate the time and the speeds of sound in air. The experiment has already been carried out, which was used to calculate the speed of sound. The speed of sound was calculated to be 330 meters per second. Echo was used to calculate the speed. Now, time is equal to total distance traveled all over velocity of sound, which is equal to 2x all over v. Now, echo, if not controlled, can become a nuisance in an auditorium. Now, imagine in an enclosed place that has 4 walls and the sound is produced at the center. You can see there will be multiple reflection of sound. The nuisance is brought about by the multiple production of echoes by wall, floor, ceiling of the auditorium. This echo, together with the original sound, give rise to a long drawn sound which confuse the listener. That's where you see a voice that has been prolonged for a particular period. Now, the continuous occurrence of echo due to multiple reflection of the original sound is called reverberation. That's when you hear this, a resounding voice that is continuous, that is prolonged. It can be reduced in awe by covering the ceiling and wall with soft perforated board or hanging of curtain round the hall. If you have been to the cinema, all the seats, the wall of the hall is being covered with a perforated board or a soft foam to reduce the effect of echo. Example: a sound waves emitted from the bottom of a ship travel at 4,500 meters per second. Let's say this is the sea, this is the ship. We also use this echo method to know the depth of a sea. A sound is being sent down. Let's say this is the seabed. A sound is being sent down. There is another equipment to receive the echo. Now, is sent vertically downward through the water of the ocean bed 750 meter deep. Now, look at it is being sent down and the echo is being received at on the same shape deep and is reflected upward. Calculate the time between the instant the sound is emitted and the instant the echo is received. Now, look at, from our formula, we know V equals to 2x all over t. What is our velocity? Velocity is equal to 4,500. And the length, the depth of the sea is 750 multiplied by 2 because the journey is to and fro. The reflection is to and fro. Waves is being sent down and it is being reflected by the ocean bed. Now, 750 to and 750 fro, which will be equals to 0.33 seconds. That is, the instant between the sound was emitted and the echo was received, the time was 0.33 seconds. A person standing 99 meters from the foot of a cliff clap his hand and hear the echo 0.6 later. Let's say, look at this cliff and somebody stands here and clap his hand. The sound wave is being sent out and like 0.6 seconds later he received the echo. Now, this is 99 meter from and 99 meter from. That means total distance equals to 2 times 99 divided by 0.6. That means the speed of sound, you can see, is equal to 33 meters. This experiment was used to calculate or to determine the speed of sound in air. Application of echo. It is used to determine the speed of sound in air, as we have seen in those examples. Then we have echo sounding, like the ship that we just talked about. The ship sent down a signal, then we have a sonar that will receive the sound. Then we use this echo sounding to know the depth of the seabed. Then for exploration of for gas and oil, different waves, sound waves, is sent into the earth crust. Now, depending on the type of rock on the wave, the wave is being sent back by reflection. Now, after analyzing the sound that is received as echo, it will now determine the type of rock, layer, and what we have, depending on the analysis on the reflected wave. Detection of submarine. Now, assignment for you to do is the same process, just you have to calculate how many holes are being made in every 2 minutes. For further reading, New School Senior Physics by Anyakowa, chapter 15. Till I come your way next time, please enjoy your day.